All right, so we talked about the fact that compound interest is exponential. It's an exponential function. And we ended up here where you have your formula, right? This formula, if you think about it, has some similarities with the simple interest. However, the rate is divided by n. N is for us the number of compounding periods, which is the amount of times that interest is calculated. And at the same time, you also have an exponent, n times t at the exponent. So this is an exponential function for that reason. Is it always better to have an exponential investment? Not always. Okay, so I gave you an example here where you've got your exponential. You start with $500 and then it exponentially grows, or you start with 2,000 simple interest. There would be a long stretch of time where you're better off going with a simple interest. But then when they meet, everything changes. Then you would want to jump on the exponential wagon and go on with that if you could make that change. So it's not always the same. If you started both at 2,000, right? If you had $2,000 to invest, so this red line would start here, you're better off doing the exponential, because then it would almost immediately surpass your simple interest. So it would have to be, sometimes it's just plugging it into your calculator and seeing which one is better is the way to go, okay? All right, so let's do an example. This is how you use the compound interest formula, okay? Okay, so Greg is 15 years old and inherited $150,000 from his grandmother. And he would like to invest it so he can use the money to purchase a house when he turns 25. So he's 15 when he gets it, and we're looking into 10 years in the future, right? And $150,000 is inherited. That's what you're planning on investing. He's got two options. Option 1, 4.5 interest rate per year, compounded monthly. The other one is same interest rate, compounded semi-annually. So I'm going to use two different colors to just make that very clear. The compounding here is monthly. The compounding here is semi-annually. And what letter do we use for compounding periods? N, obviously, not so obvious, like it should be C, compounding. So let's put next to option 1, we'll say that N is what? If it's monthly, then N should be 12, right? Because it's 12 times a year. If it says compounded semi-annually, then N is what? It's 2, right? Twice a year. So just by reading it, you already know what your compounding period is. I wonder, should I use simple interest formula here? No, don't use it. Compounding, forget about simple interest, okay? A, calculate the future value of each option. We'll do that first. So we're going to do A here. The formula is as follows. And you just basically plug in and go. A is equal to, what's the principal here? In this case, it's the $150,000 inheritance. 1 plus, my interest rate is 4.5%, so that is, it's this as a decimal. I need to divide it by, N for that first option is 12, right? To the power of 12 times, how many years are we talking here? 10 years. I'm just going to do on the side here, because you're going to have that quite often, is 25 minus 15. So you subtract and the h at the end, h at the beginning. So that's 10 years, a 10-year investment. So we go times 10. I'll highlight N, 12 here, using orange or whatever I used up there to highlight compounded monthly, right? This is option 1, right? And so clean it up a little bit. So basically what I do is I clean up whatever's inside the brackets. So if you use your calculators, I do this part first here. So I go 0.045 divided by 12, right? And then I add my result, I add 1 to it, so plus 1. That gives me that inside the bracket. So 1.00375 to the power of 12 times 10. We can do mental math there, right? But if it's some decimal, you could have time as a decimal. Okay, just warning you. But it's 10 years, so it's 12 times 10. That's 120 is your exponent. I just want to make a note here. That 120 tells us interest calculated 120 times. Okay, in this particular investment, interest will have been calculated 120 times over your 10-year stretch. So whenever you multiply your compounding period by the time, and you end up with an exponent, that's how many times it will have been calculated over the 10-year stretch. And now, I come back to my calculator. I have this in my calculator, so I'm going to copy paste it. I'm going to use the hat button to raise it to the power of 120, right? And I end up with that. So it's 150,000 times 1.5669, and that keeps going. Do not round that. And then you just multiply these two. So your future value 10 years from now will be $235,048.92. Okay. I'm going to ask you to try this right away. Right next to this. This is option 2. Using this formula, I want you to calculate how much money would be in the account under that second option. The only thing that changes is what? In this case, the only thing that changes is our 12 gets changed to a 2. Okay, because we're only compounding twice in this example here. Give it a try, see what you get. All right. Let's try to see what happens here. Still same amount to start me off. You can take some shortcuts. I'm okay with that. Just there should be a significant amount of work along the way. Okay, so in this case, I've got the 2 there and the 2 there. Clean it up a little bit. So grab your calculator. I would recommend divide that by 2, then you add 1 to it. That's 1.0225 to the power of 20. Very good. Then I raise that to the power of 20 right away, right, to give me 150,000. 1.560, and then some. I multiply that by 150,000, and you get 234. That's when you have your dollar sign at this point. 234, 76, 38. So which one gave us more? The first one. Everything else the same. More compounding means more money in your pocket if everything else is the same, okay? So I will make a note here. Okay. More compounding results in higher returns. All else the same. And by that I mean same interest rate, same amount you're investing. If everything else is the same, but we're just looking at compounding periods, more compounding is better. What would be even better than monthly, if I asked you? What's a bigger number than 12? Weekly, that would be 52. Bi-weekly, that would be 26. Daily compounding, 365. You can't beat daily, right? I mean, you could do hourly, but I've never heard of that, right? But if you get daily compounding, that'd be the best, right? 365 times a year, interest is calculated. So the snowball grows faster, okay? All right, let's answer the rest of the things here. It says B, it says how much interest did we earn? And remember, always remember that this is always true. The future amount is always principal plus interest. That is never going to go away. That is always true. The amount you hold is always comprised of principal, which is how much you have put in, plus the interest you've earned. Okay, that's always a principal that never goes away. So in this case, therefore, I could simply say to find interest, what will I do? What happens to the P when it comes over to this side? It subtracts, correct? When P comes over and you're left with I on the side, interest is always take A and P away. Subtract them. So interest would be 235,048.92 minus the 150,000 we started with. So this is you earned $85,048.92. For option 2, the same thing. So we are at 234, 76.38, subtract 150,000. That is 84,076.48. So I'm doing both side by side there. And obviously, we're not surprised that we earned a little less, okay, because the final future value was less. What is C asking for? C is asking for the rate of return for both options. Rate of return in this case would be what? Interest earned or just, you don't have to call this necessarily interest, but it's just your earnings. And in this case, your earnings is that interest you've earned, divided by principal times 100. So we will go 85,048.92 divided by 150,000. You get 56.70%. Sorry, I forgot the times 100. C on the other side, rate of return is 84,076.48 divided by 150. Multiply that by 100. Your rate of return there is slightly less. But this is also your ultimate, this is the ultimate way to answer a question about which investment is better. And it's not by much, but slightly better is the first option, right? You got more money back for what you put in, okay? I think we're good. You got 50 cents on a dollar back, almost 50%, right? Half of what you put in. So if you put $1 in, you get half of that back in profits. D, what can we conclude? We kind of did this already. If time, principal, and rate are equal, then a greater compounding period results in higher profits. This is for investments, okay? Let me bring this up so that folks in the back don't have to. If time, principal, this is probably how you feel, right? Let's not go over. First thing in the morning, math. If principal, time, and rate, if that's all equal, and I'm like, which compounding period will result in the highest return? You always want to look for the highest number. So actually think of a number. Weekly, what is that number? It's 52. Right? Daily, it's 365. 365 wins. Right? So just remember that. But some students think it's always better higher compounding periods. Not necessarily. If the interest rate is higher on the other investment, you might still be better to go with that one. Okay, so it's all about, you have to do the math. You have to do the math if it's not all the same. I'm going to skip a few pages to get to the second part of compounding period, like this formula. So if you follow me, we're going to skip that rule of 72 for now. Let's go straight to page 20. Variation of compound interest. If a question asks you to determine the principal, you need to substitute in what is given and isolate P using algebra. Okay? See you tomorrow. Zach has accumulated $45,000 over 3.5 years. His rate on the bank statement shows that he's earning 3.99% compounded daily. How much did he start with? And, some students actually appreciate having an inventory like this before plugging in right away. So let's do it. Time, we know it's 3.5 years. Remember, time has to be in years. N is our compounding periods. It's daily. So that means 365, right? Because it's daily. Our rate is 3.99%. We can't use percentages. There's one exception, and I'm going to show you that a little later. The rule of 72. Okay, so you got your rate. Between principal and A, future value, which one do you think we have? Do we have the principal or do we have the accumulated value, the future value? We have the future value, the accumulated, like how much has been earned altogether at the end of the day. This is accumulated. So this is A. They don't say invested 45,000. It says now has. After all this time has this much. So we have the 45,000 here. Okay. So this is our question mark. Could I have used simple interest here? Isaiah, you say no, why not? Because it's compounded, right? So this is, don't use simple interest. And you wonder, why does he say that all the time? I would never do such a thing. Because a lot of times this happens, right? A test even, not even exam, test, like, oh, simple interest, I equals PRT. But what about compounding, right? You have to have a compounding element to it. So let's use the formula. Okay. We know 45,000. We don't know what P is. 1 plus 0.0399 over 365. Yeah, let's put that in brackets maybe. It's probably better. All of that to the power of 365 times 3.5. It's ugly, but we have a calculator. A calculator can solve it all. So this is what I'm going to do here. I'm going to slowly clean this mess up. So I'm actually going to copy down the 45,000. That's not going to go anywhere yet. P stays. I'm going to do whatever's inside the bracket. I'm going to figure this part out. So I go 0.0399 divided by 365. And look, there's an e to the negative 4. Don't worry about it too much. We add 1 to it, plus 1. So inside the bracket is 1.00010, all of that. Let's figure out 365 times 3.5. That is 1277.5. And yes, it's weird to have a decimal as your exponent, but that's just part of this process. These are all numbers here. We can still simplify this further. So I'm going to copy this number from my previous work, bring it down here. I'm going to raise it to the power of that number that I calculated previously, 1277.5. Hit enter. And you get that, 1.14. So it's 45,000 is equal to P times 1.149, and that keeps going. So now the exponent is gone, right? I've raised that to the power. It's just a number here, no exponents. And this is your last step here. This isn't very common, but I still want to prepare you for it. We divide both sides by whatever is inside here. So cancel that out. and I'm going to go 45,000 divided by the number I have on my screen, and there you go. So you invested 39,135.12 is your answer there. So Zach started with a principal of, that's not going to fit in there. Let's try here. 39,135.12. Okay. So you will recognize this one because, right? It's like, oh, P is missing. So I gotta, and don't be too overwhelmed. Just clean up everything that you've substituted. Just clean it up until you just get one number. Okay. Okay, 39,000. So I'm gonna pause there for now and let page 23 here. Determine the total number of compounding periods in each compounding situation. So if you're getting weekly compounding over 200 weeks, okay, total compounding periods is 200. That's just, this, here you didn't have to do any calculating really. But let's try A here. An account is compounded monthly. This tells us that N is equal to 12 over 15 years. So then N times T would be 12 times 15. So you multiply compounding periods times the time in years. That'd be 180. So just try that real quick. This is just to get you over the fact that you need to always go N times T. There are some exceptions here. Watch this one. C, an account compounded daily. If it's compounded daily over 100 days, what is time in here? It's in days, correct? So the answer, if it's like this, don't multiply these. You're like, oh, it's daily, and we're talking 100 days. The answer is 100 compounding periods. That's it. The alternative would have been to turn this into years. So 100 over 365, right? You turn that into years, then multiply it, but you'll get 100 regardless. Anyways, give it a try. Maybe I'm talking too much. You'll figure it out.